So here we have the graphs of two functions, and we're looking for the zeros of the functions, in other words the solutions to the equations that would go with them. We're not told what the equations are in this case, but we don't need that to write down what the solutions to the equations would be. So remember again, the solutions to an equation are the places where the graph touches the x-axis. Now this one, let's blow it up a little bit. We can see that this one only touches the x-axis, sorry about that, at one point. Okay, now there's -1, -2, -3, so this is -2.5. Okay, so this is x equals -2.5. Now, I can make this a little bit smaller again. The thing about this graph is that the graph touches the x-axis but doesn't cross it. Okay. So what we can do is we can describe x equals -2.5 as a repeated root, or a repeated zero, or a repeated solution. X equals -2.5. Let's call it a repeated root. Okay. Okay. And that's because excuse me. That's because the graph touches the x-axis there, but it doesn't actually cross it. X equals -2.5 is a solution still. Okay, that doesn't change. It's still a solution to the graph. But because the graph doesn't actually cross the x-axis there, we call it a repeated root. Now, in this graph, the situation is slightly different. Both of the graphs that we're looking at in this example are n-shaped concave down graphs. And this one crosses the x-axis twice. So it crosses it here with x equals 2, and it crosses it here, which seems to be x equals, there's 0, there's -1, so it's between 0 and -1. Let's make it -0.5. -0.5. Oh, sorry, this is what you want here. So the solutions here are x equals -0.5 and x equals 2. Now the graph crosses the x-axis here, so we're not talking about repeated roots. These are not repeated roots or repeated zeros or repeated solutions. They're just regular solutions because the graph crosses the x-axis at those points. Okay, thank you for watching.